You gave up a month ago? No, that's no good. Y equals x sine x. We want to take the derivative. So I'll start it off. Y prime equals, what do we do? So you need to see that this is two functions being multiplied together. Okay? This guy times this guy. I'm going to call this f, and I'm going to call this g. You have to see that. If there's a plus sign in between, then you just take the derivative of each term. So this is going to be product rule. And we need to remember what the product rule is, because probably from last time we totally forgot it. It is f prime g plus g prime f. Now I will say that because this is addition going on, you can reverse the order of these terms. And because this is multiplication, you can reverse the order of these functions. Okay? But it is f prime g times g prime f. Generally, that's how I remember it, and that's how I do it when I do it. Okay? So if this is f, then I'm going to write very formally, and this will be like the second to last time that I do this very formally from then on, and it'll be just in my head. I'm going to write f prime is going to be d over dx of f, which is x, times the original g, which is sine x, plus the derivative of g, so I'm going to write d over dx of sine x, times the original f, which is just x. So that's the very pretty formal notation to set up the problem. So now we have y prime equals, the derivative with respect to x of x is 1, and then times sine x is just sine x. Then I have plus the derivative with respect to x of sine x, which is what? Cosine x. So that's plus cosine x, and then times x. So at the end I'd have times x, or I could squeeze that x in right there. Sine x plus x cosine x. The derivatives are done. There's no way to simplify that, so that's the answer. Got it? Good. The key is recognizing when to use the product rule. Two functions are being multiplied together. Do we have two functions being multiplied together on this one? Yeah. So what are we going to call f? Square root of x. And then this would be g. Okay? So now set up the product rule using the very formal notation. Y prime equals, good, d over dx of x to the 1/2 times the original g sine x. Then what? Plus d over dx of g, which is sine x, times x to the 1/2 square root of x, the original f. Okay, so it's set up. Now we can take the derivative. Y prime equals the derivative with respect to x of x to the 1/2, which is 1/2 x to the negative 1/2, right? Which you can rewrite as 1 over 2 x to the 1/2 times sine x. Plus the derivative with respect to x of sine x is cosine x. So that's cosine x times x to the 1/2, which I can write out front. Okay? Are we done? Something we haven't talked about much yet is how to simplify something that looks like this. This can and should be simplified. You actually made it harder by writing it in this format here. So I'm going to rewrite this. This becomes y prime equals 1/2 x to the negative 1/2 sine x plus x to the positive 1/2 cosine x. The question is there a GCF here? And if so, what is it? There is a GCF here other than 1, but it's not x to the 1/2. If I had x squared plus x to the 3rd, is there a GCF there? What is it? X squared. You went with the lower exponent, right? Which exponent is the lower exponent there? Yeah, so x to the negative 1/2 is actually the GCF. Okay? Now, if you pull out the x squared here, you're left with 1 plus x. How did you get this exponent right here? You subtracted. Okay? What you're doing is you're factoring out what we call the least powers. This is a method, I guess, that you can follow to simplify problems. We're going to be factoring out least powers a lot in here, and this is the first time you've seen it. So the least power here is actually x to the negative 1/2. Okay? What about the least number that can be factored out? Is there a GCF number that can be factored out? Seems like no, but actually the answer is yes. It's 1/2. So I'm going to factor out a GCF here. Y prime equals 1/2 x to the negative 1/2 times sine x. Good, we pulled that whole thing out right there. Plus, if I factor x to the negative 1/2 out of x to the 1/2, what do I get? X to the 1? Okay, so this is how you do this. Take the bigger exponent, because we're taking the bigger exponent minus the smaller exponent to wind up with the new result. Okay? Yeah? I mean, that's what you did here. The bigger exponent minus the smaller exponent to wind up with the new result. So the bigger exponent here is 1/2 minus the smaller exponent, which is negative 1/2. 1/2 minus negative 1/2 is 1. So you're left with x cosine x. But we factored out that 1/2. So that's basically dividing by 1/2 every time you look at each sequential number, okay? Like if I had 2x squared plus 6x to the third, I'd factor out a 2x squared, right? And that would turn this number into a 3. Basically, you took that number and divided by that number, okay? So this number here is a 1. If I divide by 1/2, what number must go here? 2. Okay, now we can rewrite this. We have a negative exponent and a fraction going on. So the 2 and the x to the negative 1/2 will wind up in our denominator. The 1 times the rest of that stuff will go in our numerator, so it just becomes sine x plus 2x cosine x over that 2 and then the x to the 1/2. There's your derivative. Look at all the space I have on this problem. That's what's frightening. 2 lines? Is it 2 lines? I think it's 2 lines. Y prime equals. Okay, so look at the problem. Step back from the problem and take a look at it. Shh. What's going on right here? So I will have to use the product rule there. What's going on here? So I will have to use, no. There's no need to use the product rule here. This is just a constant times a function. This is a function times a function. This is a constant times a function. So you don't need the product rule on that one. All right, for the first one, like I said, the last 2 problems were the last 2 times I was going to be very formal about the way I wrote this. I need to know f prime g plus g prime f. I need to know the product rule. So let's do f prime. If I call this f and this g, f prime will be 2 times the original g, which is cosine x, plus I have g prime f, right? But I'm going to write, since I'm dealing with a regular function times a trig function, I'm going to write f first. So plus 2x, and then the derivative of cosine is negative sine. So I'm going to make this sine x, and then I'm going to change my plus to a minus. Okay, move on. Next part, I don't need the product rule on, so it's going to be minus 2 cosine x. That's the derivative. The calculus is done. Now you just need to simplify if it can be simplified. We have 2 cosine x minus 2x sine x minus 2 cosine x. The 2 cosine x minus 2 cosine x disappears, and I'm left with y prime equals negative 2x sine x. Done. 2 lines. So that's enough of the product rule. You're going to be using it all year long. The quotient rule is another one you're going to be using all year long, and you will use it anytime you're dealing with rational functions. Just like with the product rule, though, make sure that it actually is a rational function, meaning a function divided by a function. In this case, we're going to call the numerator f and the denominator g. Just like in the product rule, we used f and g. So the quotient rule is useful for functions that have 2 functions being divided, such as that. We will call the numerator f, we'll call the denominator g, and once I do that, then the derivative with respect to x of this top f function divided by that bottom g function is this. The original g times the derivative of f minus the original f times the derivative of g, all divided by g squared. I'm going to rewrite this as f prime of x equals f prime g minus g prime f over g squared. The note here says, very important, order matters. With multiplication, the order doesn't matter. G times f prime times g, perfectly fine. Same thing here. F times g prime times f, order is fine there. But with that subtraction right there, it has to now be in that particular order. F prime g minus g prime f, and then divided by g squared. That's the original g squared. So our first example, f of x equals 5x minus 2 divided by x squared plus 1. This is clearly a rational function where we have a function divided by a function, okay? So we're going to call the numerator f and we're going to call the denominator g. That means I'm going to use the quotient rule. I have 2 functions being divided. The quotient rule, again, is f prime g minus g prime f, all divided by g squared. I could write this out using formal notation, but I'm not going to. I'm just going to go straight into taking the derivatives and simplifying things down, okay? F prime of x will be, so the derivative function of our original function will be, f prime is 5 times the original g, which is x squared plus 1, minus g prime, which is 2x, times the original f, which is 5x minus 2, all divided by x squared plus 1, g squared. We've taken all the derivatives we need to take. The calculus is over. We just need to simplify this. So we have f prime of x equals, I can distribute in the numerator, and I get 5x squared plus 5. I can distribute here as well, and I get negative 10x squared plus 4. X, thanks. And all divided by, I'm going to leave the denominator alone, x squared plus 1, quantity squared. Combine like terms in the numerator. We have 5x squared minus 10x squared, which is negative 5x squared. Then we have the plus 4x, then the plus 5, all divided by x squared plus 1 squared. That's it. Go ahead and try the second one. All right, what should I do for this one then? What? Oh, assign f and g. So the numerator is f, the denominator is g. So g prime of t will be, f prime is 2t times the original g, which is 2t minus 7. It's just fun to say. Absolutely. Next. What? The original G? Yeah. I don't know. Just fun to say. Now what? Minus what? The derivative of G, which is 2, times the original F, which is T squared plus 2, all divided by 2T minus 7 now squared. Don't FOIL that out. Now simplify. G prime of T, holy cow, equals 4T squared minus 14T minus 2T squared minus 4 all over 2T minus 7 squared. G prime of T. Combine like terms in the numerator. 2T squared minus 14T minus 4 all over 2T minus 7 squared. Okay, now one thing I want to say, that's correct by the way. One thing I want to say is you might check the numerator to see if it can be refactored, and then maybe something can divide out just to like reduce your fraction like we would normally do in Algebra 1. Sometimes they will divide out. Sometimes there'll be stuff that goes away. It happens. But what I would not do is worry about the GCF here. There's a GCF of 2. I'm not going to worry about that because it's not going to help me. If there was a 2 down here, then yeah, sure, I would take care of that. But it's not going to reduce, so don't bother. Okay, this is the answer. Okay, something that you might have to do is rewrite the function to get rid of a rational numerator. In this case, we have this division by x here in the numerator. That's really going to mess with our ability to use the product rule. Or not the product rule, the quotient rule. You can see that we are going to be using the quotient rule here with that function divided by a function. Okay? What I want to do is get rid of this situation here. To do that, I can multiply the top and the bottom by x. X divided by x is just a fancy 1. So I'm not changing anything. I'm just kind of reformatting the way this thing looks. Once I do that and I distribute this x in, I wind up with 3x minus what? 1. Yeah, x over x right here turns into 1. Then over, I distribute that x in and I get x squared plus 5x. You do want to distribute there, otherwise you're going to wind up with a product rule situation on top of a quotient rule situation. Which we are going to have, by the way. We'll get to that. For now, we just need to learn the product rule and the quotient rule separately. So now we can take the derivative of this. Y prime equals f prime, which is going to be 3 times the original g, x squared plus 5x. See, this is fun to say. Minus g prime, which is 2x plus 5, good. Parentheses, the original f, which is 3x minus 1. Okay, so we can see that as we simplify this, we're going to have to FOIL. All divided by, parentheses, x squared plus 5x, the quantity squared. The derivative is taken, which means the calculus is over. Now we have to do algebra. Y prime, don't say yuck, equals 3x squared plus 15x. Algebra isn't that bad. Minus, and I'm going to use parentheses to help me remember that this is a minus sign. So open up parentheses and then FOIL. 2x times 3x is 6x squared minus 2x plus 15x minus 5. All divided by x squared plus 5x squared. Quotient rule. I'm an equal opportunity blocker. So now we simplify the numerator. Equals, I do like that negative 3x squared. So that's a positive 15x minus negative 2x, which turns into plus 17x. But then minus 15x would be 2x, so plus 2x. And then I have negative 5, so plus 5. All over x squared plus 5x squared. Let's do this one now, and I'm going to give you one more before the end of the day. So I need to do what? Multiply the top and the bottom by x, and that is going to be distributing. So this becomes 2x minus 1 over x squared minus 3x. Okay, so now we're ready. Y prime equals. So f prime, which is 2, times the original g, which is x squared minus 3x. See, it's fun to say. Minus 2x minus 3 times 2x minus 1, the original f, all over the original g squared. He's the original g, not fake. Y prime equals minus 6x. So what I'm going to do here is I'm going to FOIL this here, and then I'm going to simplify that there so that I don't make sign mistakes. This becomes 4x squared minus 2x minus 6x, so minus 8x, plus 3. So I have minus 4x squared plus 8x minus 3 all over the x squared minus 3x squared. Now simplifying is just a matter of combining like terms without worrying about negative signs. So this is y prime equals negative 2x squared plus 2x minus 3 x squared minus 3x squared. Done. And remember what it is that we just found. What is this? The derivative, which is the derivative of the original function that tells us the slope of the tangent line at any x value. Okay? Always remember what it is that we're doing. All right, go ahead. Most of the time when I give a problem like that, people jump right into the quotient rule because they see division going on. That's a constant, yeah. So you could actually separate this out. And really, even if I had like 6x in the denominator, you don't need the quotient rule there either. Split it up into separate terms, simplify it down, and then you can take your derivative normally. So this rewrites as x squared over 6 plus 3x over 6, which reduces down to x over 2. You don't need quotient rule at all on this. This is just straight up taking the derivative. Y prime equals what? 2x over 6, which is x over 3. Wow. X over 3. Plus 1/2. Done. The point is, just because you have a bazooka doesn't mean you need to fire it at your arm when a mosquito lands on it. Right? Just swat it away. You don't have to use all of the tools in the toolbox to solve your problems. So analyze the problem first and see what process you have to follow. In this case, way easier than the quotient rule. Here's a question for you, and then we'll be done. Could I use the quotient rule on this problem? Could I get the right answer in the end? It'd just be a lot more work. Yeah. Because you'd wind up with the original g squared, which would be 36. So you can tell that you're going to be doing some reducing to wind up with a 3 and a 2 in the denominators.